Assalamu alaikum, my name is Mahatir and today we're going to learn about quantum number. So at first, if you want to know my location, if I ask you that where do you live and from where you're seeing this video from, then you have to answer like this. Inside Chittagong, you live in DOHS and in there your building is in road number 2. It's just a guess, and in the road number 2 your house number is 6 and flat number 2, just a guess. So by this information you can know my state, you can know my location like this. After knowing this information like Chittagong, DOHS, road number 1, flat number 2, you can know that where do I live. So the same theory goes for the quantum number. So if I draw an atom like this, sodium atom, so this is a sodium atom, and if I want to locate the 6th electron of this atom, then I have to know some certain numbers. Those are called quantum number. The quantum number is a kind of number by which you can know an electron's location inside an atom. You can know the size, the shape of an orbital inside and you can know at which direction the electron is rotating inside the atom. So here goes. Like, if you ask me that what is quantum number? The quantum number are the numbers that describe the position and energy of an electron in an atom. They tell us which energy level the electron is in, what shape the orbital is, how the orbital is oriented in shape. You can know the 3D and 2D shape of an orbital by these numbers, by the quantum number. Which way the electron is spinning, you can know the direction of the rotation of electrons. So in generally, quantum number is a kind of number it's 4 kind of number by which you can know an electron's location. You can know. Earlier I've said that the quantum numbers is a 4 kind of number. So these are the first kind of number is principal quantum number. The second is azimuthal quantum number. The third one is magnetic quantum number, and the fourth is spin quantum number. So let's see what is principal quantum number. So principal quantum number is denoted by the small letter n, and the value of n starts from the positive integers 1, 2, 3, and it goes on like that. This quantum number was invented by the scientist named Niels Bohr. So why is Niels Bohr called the inventor of this quantum number? Because he was the one who corrected all the Rutherford's atomic model limitations. He was the one who invented the energy level. He was the one who said that the electrons rotate in a certain orbital inside an atom. By this quantum number, you can know the size of an atom, the size of an orbital. So if I draw 2 atoms, one is sodium and another atom is neon. So you can see that this atom is, the shape of this atom, the size of this atom is larger than this one, because the max number of n in this atom is 3 and the max number of n in this number is 2. The value of n indicates the orbital of an atom, like this. If I draw an atom, So there are 4 orbitals in this atom. The first orbital is indicated by 1, second is 2, the third is 3, and the fourth one is 4. Each and every of this number has their own names, which is denoted by a capital single letter. And the first, the one is this one is indicated by the letter K. 2 is indicated by the letter L. 3 is M, and the 4 is N. So the first shell of an atom is called K shell, and the second is called L shell, the third is called N, and the fourth one is called N. So if you ask me that, if you ask me that, what is the name of the third shell of an atom, then I will say that it is the M shell you are talking about. So let's go. So that's all about the principal quantum number. And so the second type of quantum number is called azimuthal quantum number. It is indicated by the small letter L, and it was invented by the scientist named Sommerfeld. It indicates the shape of an orbit inside an atom. But there's a catch. The value of L wholly depends on N. So what's the condition? The condition is L can never be equal to N. So what's the value of L? Then L will be from 0 to N minus 1. So what does it mean? So if I say that N is equal to 4, then we have to put the value of N in here from 0 to 4 minus 1, from 0 to 3. So the value of L will be from 0 to 3. That means 0, 1, 2, and 3. But the value of L can never be 4 because because there is a condition that L can never be equal to N. So I've said that it indicates the shape of an orbit, and if the value of N is 4, we get this as the value of L. Each and every number of L has their own names, and they are that L is equal to 0, 1, 2, and 3 for the value of N equals to 4. Then this number of L is named as sharp. The second value is principal. The third is named diffuse. The fourth one is named fundamental. So in short, they're called S, P, D, and F. 0 is called S, 1 is called P, 2 is called D, and 3 is called F. In class 10 you have learned this. So earlier I've said that the value of the azimuthal quantum number denotes the shape of an atom, the shape of an orbital. So for the value of L equals to 0, the shape of the orbital will be like this. The electron will rotate in this motion, in a circular motion, for the value of L equals to 0. Then for the value of L equals to 1, the electron will rotate in a dumbbell shape. And for the value of L equals to 2, the electron will rotate in a double dumbbell shape, like this. But in case of value of L equals to 3, the rotation of electrons gets complex, so we cannot draw this. We'll just write complex for L equals to 3. So these are all the information about azimuthal quantum number. But the thing I haven't mentioned is azimuthal quantum number is also called subsidiary quantum number. So let's go to the next slide, which is magnetic quantum number, and it's the third type of quantum number of the quantum numbers. It is indicated by the small letter M, and it was invented by the scientist named Zeeman. This quantum number indicates the 3D shape of an orbital. But here also there is a catch. Before I've said that for the value of L, it is dependent on L, and in here the value of M is dependent on L. So what will be the value of L? The value of M will be from plus L to minus L. It means that if the value of L is equal to 2, then the value of M will be from plus 2 to minus 2. It's like you're taking these numbers from a number line. So the value of M will be plus 2, plus 1, 0, minus 2, minus 1. So if the value of L is equals to 3, then it means the value of M will be from 3 plus 3 to minus 3. It means it will be plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. 4. Then it means the value of L will be from 0, 1, 2, and 3. And for the value of L of this, the value of M will be, for 0, the value of M will be 0 only. And for 1, the value of M will be plus 1, 0, minus 1. Then for 2, plus 2, plus 1, 0, minus 1, minus 2. And for the 3, it will be plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. So every suborbital has their own divisions. So this is the fourth quantum number, and it is indicated, it is a spin quantum number. It is indicated by the small letter s, and it has just two values. It starts from plus half to minus half, and it denotes the direction of rotation of an electron. So if I write the electronic configuration of any atom like sodium, here the s orbital has its division, doesn't have any division because the value of L is equals to 0. But for the p orbital, there is a division of 3 division. There's 3 divisions. This is called PZ, it's PX, and it's PY. At first, the first electron will come like this, and the second electron will come to the second box, and the third electron will come to the third box. After that, the fourth electron will go in this bottom of the first electron, like this. This is the fourth, it's fifth, it's the sixth. So for the direction of the electrons in here, you will know the value of the spin quantum number. So for this direction above, the spin quantum number is plus half, and for the direction of downwards, the spin quantum number is minus half. Problem and the question is determine the 4 quantum number of the 6th and 7th electron of sodium atom. So if first of all, before solving this question, we have to write the electronic configuration of sodium atom. The electronic configuration of sodium atom will be, so for s orbital, the s suborbital, the division will be this, and for this it will be the same. And for the p orbital, the division will be like this. It will be in 3 boxes. So we have to know the location of 6th and 7th electron. The first 2 electrons will go like this. The 3rd and 4th will be like this. And there will be the 5th and 6th and 7th. So in this electronic configuration, we have got the location of the electron in the shell. In the shell. So the value of the principal quantum number will be this, which is the value of n. N equals to 2. Then for the value of 2 equals, for the value of n, L will be 0 and 1. But there is only a p. So it means a p is equal to 1. So the value of L will only be 1. And what will be the value of m? So each and every of this box have their own names. It's a number. So the name of this box is -1, and this is 0, and it is +1. So the 6th electron is in the 0 number box. And for the S, the last quantum number, the direction of the direction of the rotation of electron is above. So it will be positive half. So this is the 4 quantum number of 6th electron, and for the 7th electron, most of the thing will be the same. The value of n will always be 2. The value of L will be 1. The value of m will be different because the 7th electron is in this box and its name is +1. And the value of L will be +half because the direction of rotation of electron is above. Then we will go to the next slide.